This is a titration. We want to classify both the acid and the base as either weak or strong. HCl is one of the big seven. We know it's going to be a strong acid. And an AOH is a strong base. So this is a strong acid, strong base titration. We can write the neutralization reaction as HCl aqueous reacting with aqueous sodium hydroxide, and the products are going to be sodium chloride and water. It's basically an ion exchange, double exchange reaction. This is a neutral salt solution. Because neither Na plus or Cl minus are going to react with water. They are both conjugates of either a strong acid or a strong base, so they will have no strength of their own. Alright. The first step is to calculate the pH of the solution at the start. So we haven't had any sodium hydroxide. Alright, so this is just a solution of 0.10 molar HCl. HCl, again, we know is going to be a strong acid, so it reacts 100% in water to produce H3O plus and chloride ion. So all of our initial HCl goes to H3O plus. So for the pH, it's the negative log of H3O plus. So we know that H3O plus is 0.10, because that's the initial concentration of the HCl, and this is equal to 1.00. Note I have 2 sig figs on our pH. We take the log of a number with 2 sig figs. We only count these decimal places after the decimal point as significant. Alright, next we want to calculate the pH after the addition of 20 milliliters of 0.1 molar NaOH. Now, at least some of the acid is going to be consumed. We want to determine how much of the initial acid we had and how much is consumed in order to determine our pH. So we have we want to calculate. Sorry, what I'm doing here, we want to calculate the initial moles of H plus. I'll call it H plus rather than HCl because that's really what we have. You can call it H plus or H3O plus. Doesn't matter. 0.10 millimoles per milliliter. I'm going to use millimoles because it makes numbers a little bit easier to work with. Remember that anything that's expressed in molar is the same as millimoles per milliliter. Okay, moles per liter is the same as millimoles per milliliter. So we have 0.10 millimoles per milliliter, and we've started with 40 milliliters of our HCl. So we have 4.0 millimoles of HCl to start. Or we were going to call it H plus. Alright, so the added hydroxide is 0.10 millimoles per milliliter. It's the same concentration as the acid, only we have just 20 milliliters of it. So that's 2 millimoles of our hydroxide. So we have 2 millimoles of our hydroxide. That's going to neutralize 2 of the 4 moles of H plus. therefore we have 2, or we can, I'll show you the math, we have 4 minus 2 millimoles of H plus remaining. Again, so we started with 4 millimoles of H plus. We've added 2 millimoles of hydroxide, which has neutralized 2 out of the 4 millimoles of H plus. So, to calculate pH, we know that this is going to be a strong acid calculation, because that's what we have in solution. What we have in solution is simply H plus ions. So pH is the negative log of H plus, or H3O plus if you prefer, and in this case it's the negative log of 2 millimoles. And now we're in a slightly increased volume, because we've started with 40 milliliters up here and we've added 20 milliliters. So our new volume is 20 plus 40, or 60 milliliters. Okay, again, millimoles per milliliter is the same as moles per liter. Okay, if we do our calculation here, this comes out to be 1.477 with 2 sig figs. Our pH now is 1.48. Continuing on, we want pH after the addition of 40 milliliters of NaOH. So, the added hydroxide, and 0.10 millimoles per milliliter times 40 milliliters. And now we have 4.0 millimoles of hydroxide added. So now all of our initial 4 moles of H plus have been neutralized. Okay, so what do we have in the beaker? Well, all of our H plus has been neutralized by the hydroxide, so all we have is a tiny bit of added water to solution. There's nothing in, no ions that are going to react with water, so at 25 degrees C, our pH is going to be neutral, 7.00. Okay, finally, the pH of the solution after 50 milliliters of NaOH have been added. So, the added hydroxide is equal to 0.10 millimoles per milliliter. Now we have 50 milliliters. So we have 5 millimoles of hydroxide that's been added to the beaker, and 4 millimoles of that has been consumed by neutralizing the acid. Alright, so what we have in the beaker is 1.0 millimoles of excess hydroxide. So we can calculate our POH. The negative log of a hydroxide ion concentration, which is 1 millimole. And we are now in a total of 90 milliliters, because we had 40 to start and we've added 50 milliliters of the hydroxide, Okay, this is our strong base calculation. Our POH comes out to be 1.95, so our pH is 14 minus POH, which is 12.05.